Men have come to this place, and men have gone from this place according to the rivers. Men's fortunes have risen and fallen as the rivers rose and fell. For we hold this land only as we hold the waters to man's timing, and direct them to man's purpose. This is the West USA, 17 states where limited rainfall makes existence dependent on water conservation. The problem is to get water from where it falls to where it will do the most good. Unless the natural supply is moved to suit man, he will be plagued with alternate floods and drought. 100 years ago, our people in the West tackled the problem of bringing the water to the land. Irrigation 2,000 miles east and west, 2,000 miles north and south. Irrigation developments built by pioneers to water their farms, by communities to water their valleys, and by federal reclamation when needs called for larger, more complex systems. By wise development of our river basins, we have made them support more people. The West has reclaimed 22 million irrigated acres from the desert, 6 million acres on reclamation projects alone, homes for 250,000 farm families, and for every farm family, several families in town. The same water that gives life to thirsty acres produces power to process the products of those acres and spark general industrial expansion. New resources, new wealth, new markets to make America strong and keep America free. Water for the earth, water for power, water for work and play. Reclamation water is all these. There was always the promise of gold in western hills. Yet the West can never yield more wealth than its water will allow. In an irrigation system office, the manager is talking with an irrigation farmer.
If you ask me, the future of not only the West, but of the whole country depends largely on a couple of things. It depends on making the best use of the water we've already got and how much more water we can put to use.
Yes, I know there's a lot we irrigators can do to make every drop count, but you fellas have to deliver it to us before we can use it. You know, we used to sort of take water for granted, but the way the whole West has been growing, it looks like we're going to have trouble finding enough to go around.
You're right, because here in the West, agriculture and industry, too, to a large extent, can grow only as fast as we get the water.
But it isn't entirely a matter of finding new water. We can gain a lot by just making better use of what we have.
You're putting your finger on one of irrigation's biggest problems. Do you realize that on many irrigation projects, about half the water supply is lost before it ever reaches the farm turnout, wasted through seepage, transpiration by weeds, and inefficient operation all along the line? You might say that for every river we put to work, we lose the equivalent of another one nearly as big.
That means about half of the developed western rivers are lost. That's as far as irrigation is concerned.
That's right. Put them all together and you'd have one of the world's biggest rivers with dams, canals, and ditches already built to put its water to work. Millions and millions of dollars spent to make the water available, and not a drop going on a farm. Lost river, you might call it.
That's a good name for it. And to think whole rivers lost when the country is so critically short of irrigation water.
But much of this tremendous loss can be saved through good management with the backing of you irrigators. Saving this water is the quickest and cheapest way we can increase western irrigation and grow more food and fiber to meet the country's soaring needs. Now, suppose we take just a few minutes to talk about some of the things we can do right here on our own system to recover our share of that lost river. Water conservation really starts on the watershed above the dam. In order to plan our season's operations properly, we have to know what the runoff will be. So we use snow surveys coordinated by the Soil Conservation Service, the state, and other groups. Precipitation measurements and long-range weather forecasts from the Weather Bureau. And data on stream flow and water table levels on the watershed from the U.S. Geological Survey. Reforestation and watershed protection by the Forest Service and others helps to protect our source of water.
Yeah, and it helps keep the soil on the land, too. That's where it belongs, not in our reservoirs.
Even with a clean reservoir, we have our problems. Seepage, for instance, can occur in spite of the best engineering and construction. Sometimes we have to grout by forcing a mixture of cement, sand, and water down through the holes to stop underground leaks. Operation of the gates at the reservoir takes a lot of careful management. The trick is to keep an adequate supply flowing without any unnecessary waste. This is often complicated by downstream power plants, flood control, and navigation, as well as irrigation. But irrigation is the main job.
That's fine. You conserve the water that goes through the valves. But what about the surplus water that spills from the reservoir?
Surplus water can be saved by diverting it into spreading basins. It percolates down through the gravel to recharge the underground water basin.
Diversion dams are not as spectacular as storage dams, but their operation is just as important.
You bet it is. Gates need to be set frequently to meet changing demands. A lot of water may be wasted by gates which aren't adjusted often enough because they're hard to operate or hard to get to. Modern, power-operated gates cost money, but they pay off in water saved. Proper management includes continuous and accurate measurement so the gate tender knows how much is going down the ditch at all times. Good management includes things like keeping sluice gates in good working order so that it will be a simple matter to sluice out silt from behind the diversion dam. This ought to be done regularly to prevent silt from getting into the canal. But it's below the diversion dam, in the canals and laterals, where we really get back some of that lost river. As common a thing as overloading a canal can waste a lot of water and lead to even more serious trouble if the ditch breaks.
I know, but sometimes overloading can't be helped. For instance, in case of a sudden rain.
Sure, but protection against overloading can be provided by flashboard wasteways. They serve as automatic safety valves by spilling excess water before it can do any damage.
Grass spillways do the same thing. We ought to have more of them.
It's even better to have small regulatory reservoirs. Then, when we're faced with an overload, we have some place to save the water. Keeping high water out of the canal prevents a lot of seepage.
Seepage. That's one of our biggest water wasters. It causes all kinds of damage. We lose not only the water, we lose the land. That's waterlogged too.
Yes, and it pays to make our canals sound and watertight. There are a lot of ways of doing it. Concrete is long-lasting. It is widely used on irrigation projects. Mortar is sometimes sprayed pneumatically over wire mesh reinforcing.
Gravel blanketing seems to be working out pretty well on the South Main Canal over our way.
Under some conditions, gravel blanketing is a simple and inexpensive way to stop leaks. Silt settles in the gravel, forming a seal. Grouted riprap is sometimes used. Where soil conditions are right, compacted earth is satisfactory, even on large main canals. Leaky banks can sometimes be sealed by jetting them with oil or mixtures of clay and water. The oil or clay penetrates the soil and forms a watertight curtain.
I notice a lot of asphalt being used lately.
Asphalt membranes, properly applied, are doing well in many localities. Asphalt is sprayed on the subgrade. Then it is blanketed with earth or gravel.
It must be awfully tough stuff.
It sure is. It took a lot of laboratory research to develop a material to stand up under all extremes of temperature, in an oven or in ice water, and tough enough to stand pressure and pounding without breaking.
A lot of us don't realize how much work is going on all the time in labs and in the field to find better ways of operating and maintaining our projects. All we see is the benefit we get from it.
It's just as important to have tight structures as to have tight canals. It's mighty poor economy to keep any kind of leaky structures in service.
I guess there's no method of ditch lining that's always best for all purposes.
Nope. It's a matter of determining which one best meets a particular situation. There's another big water thief, weeds. Weeds, brush, and trees take a large toll of water if we don't keep fighting them all the time. They not only steal water, but clog up the canals and laterals, cut down the flow, and force us to overload canals to meet your needs. Sometimes the growth will stop the whole show if it isn't checked. 1 acre of stuff like this uses enough water to irrigate 2 acres of average crops. We have to use everything in the book to keep them under control. Drag lines where the going is really tough. Dredges, which leave a clean canal behind them. Another types of earth-moving equipment. It's a strange kind of amphibious warfare, with chains dragged in the water to destroy moss and water weeds. Discs to cut underwater growth. Chemicals to kill moss in the water. Sprays to kill brush and weeds on the bank. Weed burners to burn them out. And just plain mowing them down. The menace can be met by more peaceful methods too, like shaping the banks and sowing them to grass.
While we're on the subject of ditch banks, I'd like to know what we can do about gophers.
Well, one way is just trap them one at a time, but it's often a tedious and discouraging business. A faster way is to get them down on their runways with a poison gas like calcium cyanide. That's mass murder from the gopher's point of view, but you have to be careful. The stuff is as poisonous to the poisoner as it is to the gophers. 1 shot kills every gopher it reaches within 100 feet or so. A gopher hole along a canal bank may look pretty innocent, but once water starts running through it, you're in for trouble.
Ditch Rider 7 calling headquarters. Ditch Rider 7 calling headquarters. Come in, please.
This is headquarters. What is it, Charlie? Over?
There's a break starting on West Lateral at about mile 4 plus 300. Looks like it started from a gopher hole. It's bad now, and it's getting worse. Over.
We'll send somebody right out. You run up to the heading and shut off the water. Over?
Roger. Ditch Rider 7 out.
Yes, all 3 trucks. Load them up and get them out there quick. Headquarters over and out. Load up number 4 dozer and send it right out.
Some years ago, a break like that would probably mean a ditch out of service for several days, washing out the crops around the break, while other ones farther down the canal were going dry. Some folks thought we shouldn't put money in a 2-way radio. Wouldn't you say it was money well spent? Thanks to radio communication, we'll have water flowing again before evening.
But of course, you don't have that kind of an emergency every day.
Oh, we use radio for other things beside emergencies. You'd be surprised how it speeds up routine operations. Let's go over and listen for a while.
Headquarters calling Ditch Rider 3. Headquarters calling Ditch Rider 3. Come in, please.
This is Ditch Rider 3.
Ed, Charlie Johnson, turnout number 7-1 just called. Thinks he isn't getting the full head of water he ordered. Can you take care of it? Over.
I'm just about there now. I'll check it. Ditch Rider 3, over and out.
That radio enables us to give much better service to our water users. And what's more important, it saves water. When water supplies are tight, or the main canals and laterals are not too big, you've got to figure all the angles. Here in this district, the ditch rider keeps in close touch with all his users. Whenever he knows he's going to have a little extra water, he tries to find someone who can make good use of it.
It all goes to show that the closer we work together, the more efficient operation we have, and the less water we waste.
Sure it does. For example, you like a constant head of water when you irrigate. We have a better chance to give it to you if you'll notify us promptly when you want the water and when you want it turned off. The more advance notice you give us, the better chance we have of adjusting your deliveries to fit in with your neighbors. We don't like to fluctuate the head of water in our canals either. Such fluctuations waste a lot of water. And there are plenty of other ways we're losing that lost river. For example, I know of places where good cropland is being destroyed by laterals with too much drop. Soil is carried on down the system to clog up the work somewhere else.
Can't checks and drops stop that cutting?
Well, we put in a lot of new checks under the Rehabilitation and Betterment Program, but we still need plenty more to make every drop of water count.
Say, I've heard something about underground pipe systems. What about them?
They're going in for concrete pipe in a big way in some areas. The initial cost is sometimes high, but once they're in, your seepage, evaporation, and weed problems are done so far as the distribution system is concerned anyway.
And underground pipe systems let you farm all your land. Where land is valuable, that can be important.
But mostly, water conservation is a lot of little things, like replacing old leaky wooden turnouts, for example. We've been putting in modern concrete structures as fast as we can, using labor-saving techniques like movable forms and prefabricated parts wherever possible. Some new type turnouts have built-in water measuring features which make it easier to deliver exactly the right amount of water into the farm ditch. With some structures, the ditch rider calculates the flow by measuring the depth of water or checking it on a staff gauge. Others are equipped with meters, which read directly in terms of the rate of delivery, or even calculate the total volume delivered. This makes it as simple as reading your electric meter.
You know, after you get the water past the turnout, there are lots of things we fellas can do to save water, like using siphons for better control.
We're working out a lot of new wrinkles with the help of the state colleges and the Soil Conservation Service. A couple of fellows in this district have installed farm pipe systems. That's an efficient way to handle water.
I've been thinking about buying one of those portable sprinkler systems.
Yes, they do a good job and save water under certain conditions, especially where soil is light and the land is too irregular to grade properly.
Leveling is pretty important. A rough field sure does take more water and more labor than a level field. Some of us leveled our old fields down a couple of years ago, and it certainly has paid off.
A well-prepared field with clean head ditches and wasteways means higher production with lower costs. There's no sense in letting valuable water spill onto the roadside or into your neighbor's field.
But drainage water isn't necessarily wasted, is it?
By no means. Reuse of drainage water is one of the most valuable conservation measures we have. With the right kind of farm wasteway, surface waste can be collected and used on lower ground.
But suppose there's no place to use it on lower ground.
In that case, sometimes they pump it back into the irrigation ditch, or they can run the drain into a river so that the water can be diverted farther downstream.
I'm beginning to see how it all adds up. A little water saved here and a little water saved there on any kind of a project, no matter how big it is or who operates it.
A lot of water users in irrigation districts are already doing a fine job. It's a job for all of us to keep on hammering at. Saving Lost River is a matter of plugging little leaks. On the watershed, at the main dam and reservoir, at the diversion dam, stopping seepage, improving operations and fighting weeds along the canals and laterals, delivering the right amount of water to the farm turnout at the right time, efficient use of water on the farm itself, and last but not least, reusing water again and again As long as there is a drop, we can put back to work.
Yes, as the manager and the irrigator agree, the West must save Lost River. Its power, its food, its homes, and its purchasing power have largely come about where water has been brought to dry but fertile acres. Water is wealth. It is the difference between desert and field, cactus and fruit, jackrabbits and good beef cattle. Through the U.S. Bureau of Reclamation alone, the American people have invested about $2 billion to harness western waters and put them to work. We reap returns in food and fiber. In a more healthful diet, more than $500 million worth of farm produce each year, hundreds of millions of dollars worth of purchasing power, linking east and south and Midwest and north into the nationwide network of reclamation benefits. All these from western rivers. We can nearly double this wealth if we save Lost River and put its waters to work. More prosperity, greater security, from wiser, better, more economical use of our precious water resources.